Okay, in this video, I'm going to have us go through the 7.4 notes. So I want you to take notes in your packet, or if you've misplaced your packet, do it online on Notability, because I had posted the electronic packet at the beginning of our Chapter 7 notes. Okay, isosceles triangles, we should remember from chapters back that they are a triangle with two congruent sides. So let's draw that for ourselves. Okay, so this is what you've known as an isosceles triangle. You can see those two sides are congruent because of the way they're marked. In this section, we're going to talk about a special isosceles triangle, and that's going to be a right triangle that is isosceles because its legs are the same length. Okay, so it's a right triangle, and these legs are the same. That makes these angles the same. Okay, there's another video embedded here that you could watch if you wanted to, talking about this as well. But for right now, this is me talking about it to you. Okay, in a 45-45-90 triangle, the hypotenuse, which we know is the longest side across from the right angle, is 0.2 times as long as each leg. So that means the hypotenuse is the biggest. Okay, we already knew that. Now, that's one way to think about it, but I'm going to have you think about it like this. Here is your isosceles right triangle, also known as a 45-45-90 triangle. If I label these sides A, then this side, the biggest, is A root 2. Okay, so for example, what could be a possible problem I could ask? What if I drew this for you, and I told you it was an isosceles right triangle, and I told you that this side was 7, and I asked you to find the two missing sides. So the other leg is going to be the same, right? So that's going to be 7. And the hypotenuse is going to be 7 radical 2. So do you see how that's working? Here's your A, here's your A, here's your A again. So if my A was my 7, here's my A again, and then here's my A, which was 7 radical 2. Those are my lengths. Okay? Okay, so this is the first special triangle. Here comes the second special triangle. And again, there's another video here that you can listen to if you wanted to. But for right now, I'm going to continue with the lesson. So in a 30-60-90 triangle, and I'll draw that for you in a second, the hypotenuse is 2 times as long as the shorter leg. So let me write out that word times so you don't think that I'm putting a variable in here. Oops, sorry. Let me get that eraser going. I don't know why it's doing that. I think it's, okay, that's better. Okay, so I'm going to say 2 times as long as the shorter leg, and the longer leg is radical 3 times as long as the shorter leg. Okay, so everything's relating back to the shorter leg. Here it is in verbiage, but I like to do things visually. I think a lot of you do better visually. So here's my triangle. This is a 30-degree, 60-degree, 90-degree triangle. The side opposite the 30 degrees will be my A side. The side opposite the 60 is going to be the A root 3. And the side opposite the 90 is the 2A. And that's the second special triangle. Okay, so you've got 2 of them. So you want to memorize these relationships. Okay, this is going to be very important for us. We're going to use this in this entire section, and we're going to do tables to solve things, do some word problems. We're going to do lots of work with this. Okay, so let's keep going. Okay, it says example 1, find the hypotenuse in a 45, 45, 90 degree triangle. So they drew that for us. I know the hypotenuse is the side across from the right angle. This, I told you, is the a root 2 side. This is the a side. This is the a side. You see how we have a pairing here of the a and the 8? So I can make that into an equation. A equals 8. Can't I then use that information, and wherever I have an A, I can replace it with an 8. Wherever I have an A, I can replace it with an 8, and now what do I have? I have all 3 sides. In terms of this 45, 45, 90, they're usually not going to tell you both angles, but you need to understand that they're both 45 if you have a right triangle, because those 2 angles have to add to 90. And those sides are going to always be equal. Okay, so that's our first example. Here's another example. Okay, so for this example, once again, here's your hypotenuse. This is my a root 2 side. This is my a side, and this is my a side. So it looks to me like I already have side lengths here and here. How will I use that a that they gave me to get the other side length? I'm just going to plug it in. So where I have an a, I'm going to say 3 root 2, and I'm going to bring this down. Okay, what is root 2 times root 2? Well, that's just plain old 2. So this hypotenuse is 6 in length. So my a root 2 equals 6 in this situation, and now I have my 3 side lengths. Okay, here comes another one. Now you may want to stop the video at some point and kind of re-listen to some of this stuff. That would be normal because it's hard to take it in all at once. And hopefully you're not trying to do something else while listening to my video. That would be a mistake. Okay, look at this next triangle. They're going to keep switching the orientations, so be on the lookout for that. Here is your hypotenuse, right there. The hypotenuse is always the a root 2 side. The legs are always the a sides. Can we get a relationship? And we can if we look right here. Do you see how right here I can make an equation by saying 5 root 2 equals a root 2? Okay, if that's the case, what's my a? If I divide by root 2 to get it by itself, that becomes a 1, so that cancels. Divide by root 2 again, up, also becomes a 1. 5 equals a, and that's what I needed. Because now if I know that 5 equals a, don't I know that this side is 5, and this side is 5, because that's the a side, so they use the variable x, so I can now say that x is 5, because that's what the leg length is. Now I have all 3 of my lengths, and I'm good to go. Okay, we're going to keep going. Okay, standardized test practice. Ooh, let's see what happens here. Okay, once again, here is my hypotenuse. It's a 45, 45, 90 triangle. This is the a root 2 side. This is the a side. This is also the a side. It says find the length of WX. WX is the hypotenuse. What do I know? I know that A is 25 because I recognize the legs are the A sides. So take your A and replace it with 25. Then bring along the root 2, and that will give us the length of the hypotenuse. 25 root 2, the units are centimeters. Here we have it. It's our choice B. Okay, now we're going to move over to the 30, 60, 90 triangle. So you should look back just to verify you understand how I'm going to mark this. This is my A side. Across from the 90 is always the 2A side, and across from the 60 is going to be the A root 3 side. Okay, look and see where you have a value, because we're going to use that value. Up there's a value right there. So what do I know? I know that 9 equals A root 3. They want me to find X and Y, which are my other two sides of the triangle. Here's my Y, it's the hypotenuse. Here's my X, it's the other leg. It's the leg across from the 30 degrees. Both of those side lengths have A's in them. Therefore, what I'm going to do is I'm going to look at that and say, if I can isolate my A over here, then I can plug it back in to my triangle and get my two side lengths. Well, I can do that because I'm going to divide by radical 3. Divide by radical 3. So A equals 9 over radical 3. Now, in our class, and in most of your math classes, they do not want you to have a radical in the denominator. So if you have a radical in the denominator, take that value, put it over itself, and multiply straight across this way. 9 times radical 3 is 9 radical 3. Radical 3 times radical 3 is 3. Can I reduce the 9 and the 3? I can. 3 goes into itself 1 time. 3 goes into 9 3 times. You cannot go into that radical. It is not the same as the numbers outside. So therefore, you're getting 3 radical 3 equals my A. Okay, we'll highlight that in green. Take your A and use it to find the missing sides. So what do we find? We find that X equals 3 root 3. And what about Y? Well, Y was 2 times A. So what is 2 times 3 root 3? Well, to multiply that, you multiply the 2 times the 3 only, and you get 6 root 3 as your final answer. So what have I found? I have found that X equals 3 root 3, and the Y equals 6 root 3. Okay, and I learned some things about multiplying radicals. Let's continue. Here's some extra practice. So this says find the length of the hypotenuse. Okay, it's a 45, 45, 90 triangle. You've got to recognize that first. Then I want you to label it A root 2. They only want this length. So they want A root 2. Can you see any values that they've given you? Well, yes, I can. I can see that this is side length 12, and that's where my A's are. So if that's 12, then I know that this is 12 because they're both 12 since it's an isosceles triangle. And my A root 2 side, I can get the value for it by plugging in 2 from 12, excuse me, 12 for my A. So what does my hypotenuse equal then? It's going to equal 12 root 2 because I replaced the A with the 12 that they told me was the leg value. Okay? You probably have to think about this a little bit. In both cases, they want the hypotenuse. So if they want the hypotenuse in this case, that's the hypotenuse. Now that's the trickiest part of it because you've got to be prepared for a change in orientation. Okay, now, these are the legs. The legs always equal A. The hypotenuse always equals A root 2. So that means if I want to know the hypotenuse, and they told me that it is A root 2, and I know that A is 10 root 2, then I'm going to replace that A with 10 root 2, and I have to continue with the root 2 that was there to begin with. And what do I have? I have root 2 times root 2, which is 20. So that hypotenuse is going to equal 20, because that's what I just discovered. Okay, that hypotenuse is 20, and that's the answer they wanted. So our first one was 12 root 2, and this one is 20. Okay, let's continue. Oh, what kind of triangle is this next one in practice 2? If these are both x's, then this has to be a 45, 45, 90 triangle, because it's isosceles. This is my A side, this is my A side, this is my A root 2 side. That's the side that has a value. Use that to get an equation. A root 2 equals 15 root 2. Get A by itself by undoing this multiplication by doing division. Those cancel, A is 15. Find the lengths of the legs of the triangle. That's the sides that I put the A's on. That's where the X was. And we just found out that they're both 15. And I would expect that they're both the same because I knew it was an isosceles triangle. Okay, so 15 is my length because the length of the legs are my A's, and I just solved my A to be 15. Okay, let's keep going. Okay, here's another 45, 45, 90. Label your triangle. This is length A, this is length A, this is length A root 2. Now let's read the equation. Triangle MNP is a right triangle. Well, I know it's a 45, 45, 90 right triangle too. Find the length of MP. What is MP? You have to recognize MP is the hypotenuse. Do I have a relationship I can use to solve for my A? I do. Look, right here. That tells me that A equals 18. If my hypotenuse equals A root 2, so the hypotenuse equals A root 2, and I just found that my A is 18, plug it right there, and my hypotenuse equals 18 root 2. And that's what they want for an answer. Okay, there is your hypotenuse, 18 root 2. I can put it right over here too. 18 root 2 is my hypotenuse because my A value they gave me was 18. Okay, let's keep going. Oh, look, they're changing triangles on us. This is 30, 60, 90. You may need to go back to your notes because this is a different orientation and different values for my supplementary or complementary angles. Here is my hypotenuse at B. Now they used A's as well, but my A's are different A's. They're using A's as a variable. I'm using my A's, and I'll do them in red to indicate how the sides are related. Across from the 30 is always the A. Across from the 60 is the A root 3, and across from the 90 is the 2A. They want to find values of their A and of their B. So where are their A's and B's? So they want this, that's their A. Excuse me. They want a B, that's their B. Okay, what do I know? I have a pairing right here. So what I know is that 15 equals A root 3. I want to figure out what A is so I can give value lengths for the leg and the hypotenuse. So get A by itself. Divide by root 3, divide by root 3. That cancels. What did we say about radicals? You cannot keep them in your denominator. You've got to multiply by radical 3 over radical 3. That is called rationalizing. Then you multiply straight across. What do you get? In the numerator, you're going to get 15 root 3, and in the denominator, you get root 3 times root 3, which is just plain old 3. 3 goes into itself 1 time, 3 goes into 15 5 times. I am getting, as a result, that A equals 5 root 3. Okay, that's a key piece of the puzzle. That's what my A is. Well, my A equals their A because we happen to have the same letters in the same spot. So that is going to be 5 root 3. What about their B? Well, their B has to be 2 times my A. 2 times my A gives me 2 times 5, which is 10 root 3. I now have both of my answers. There's one, there's the other. Done. Okay, we're going to keep going. And what we are looking at right now is some of the homework. So we've only really practiced one of these 30, 60, 90. So I'm going to do another one for you down here so that you can practice it again. So let's get a 30, 60, 90 triangle. I'm going to change the orientation. I'm going to make this 30 and this 60. I'm going to tell you to label your triangle right away. This is the A side. This is the A root 3 side. And this is the 2A side. What if I told you that the hypotenuse was 10? Can you solve for the other two sides? Well, the fact that the hypotenuse is 10 matches up with my labeling to give me an equation. 2A equals 10. Get A by itself, divide by 2. So A is 5. That is critical because I can now plug in 5 right here, and I can plug in 5 root 3 here. And now I have both of the side lengths. 5 was the A, and this is 5 root 3. Okay, so I have both of my side lengths. Let's do one more like that. So here, I'm going to make this 30 this time and this 60. Label your triangle. Across from the 30 is the A. Across from the 60 is the A root 3. And across from the hypotenuse is the 2A. What if I tell you that the leg across from the 60 degrees is 7 root 3? And I want you to identify the other two lengths. This leg right here and this hypotenuse right here. Look to see where you can make up an equation. Right here you can. You can say a root 3 equals 7 root 3. Divide both sides by what? By root 3 so that you can get a by itself. The root 3's both cancel and you get a is 7. That means you can use this a, and that side length was a, so it's 7. The hypotenuse was 2a, so it's 14. Okay, so we've done 3 more examples. So hopefully that helps you. So let's look at this. We have these problems to do. So I'm going to do one now. I'm going to have you do all the other ones for the async homework day. So let me just look and see what looks like the hardest one to do, and I'll do the hardest one. Okay, I found it. So I think the hardest one to do is 6. So this is 45, 45, 90. To make this nice and big, here's our example. Across from the 45s are the side lengths that I've been labeling A. Across from the hypotenuse, across from the right angle, is the hypotenuse, and that is a root 2. Okay, I need to solve for A. Can you get an equation? And you should say yes. Here is my equation. My equation is 10 equals a root 2. I need root 2 by itself. Divide by root 2. Divide by root 2. I can't leave a root 2 in the denominator, so I have to rationalize it by multiplying by root 2 over 2 and then multiplying straight across. That is 10 root 2 over root 2 times root 2 is 2. I can reduce that by putting 2 into itself 1 time and 2 into 10 5 times. So that's going to equal 5 root 2, and that is my A. Once I get my A, I know that that is 5 root 2, and this side is also 5 root 2 because it's isosceles, and these two sides are equal, and they were my A sides. Okay, next thing. I'm going to do one of these problems. Now, these definitely look a little bit more challenging, and I think the most challenging one may be this one right here in the number 1 position. So let's label our triangle. I'll make this nice and big so you can see it. Label this. That's your hypotenuse. That's going to be in a 30, 60, 90. What is that? Well, that is my 2A side. Across from the 30 is my A side, and across from the 60 is my A radical 3 side. Okay, things for you to memorize. My goal is to get A by itself so I can solve for the other two sides. So here comes, I have to get a relationship, and I have one right here. So I can say 2A equals 6 radical 5 over 5. Oh dear. Divide by 2, and watch what I'm going to do. Divide by 2. Okay, when we divide and we have fractions, we actually keep it, change it, and flip it. A becomes 6 radical 5 over 10. And you can reduce by dividing the numerator and the denominator by 2. That can be 3 radical 5 over 5. That's my A. Okay, so let's play with this. If this is my A, then I know that this side is just exactly what I just solved for A, right? All set. Now look at this side. I have the 60-degree side and it has a root 3. So I'm going to take where you have the a and write 3 radical 5 over 5. Then multiply by the radical 3. Now, here comes a lesson in multiplying under radicals. To get that product, I write down the 3, I put a big old radical sign, and I multiply 5 by 3, and I get 15. All over the original 5. You cannot put that 5 into the 15 under the radical. So remember that radical kind of closes the door. It's not going to let a plain old 5 in. So you are done when you get to this step right here. Okay, so that's going to be what they wanted for their x. This one over here, which I'll highlight also, is what they wanted for their y. And they gave us the other hypotenuse value. Okay, so we're going to try to do some of these for homework. And then we're going to talk about this when we come back to school after the async day. So I'm going to have you post this stuff, these 2 homework pages. So page 22, which is right here, and page 21, I believe those are the same pages in your packet. That's going to be our homework on the async day. Okay, I'm going to post this video today. You may need to review this video again because it was a lot of really good information. And when you come back to class, we will go over all this and we'll do a lot of practice. Okay, things to look forward to. Thank you for listening.